All right, so this lesson is going to be on 5.4 logarithms, and 5.4 is going to be actually separated into two lessons. So this one's going to be part one. We're going to start off with the definition. Logarithm is the inverse of an exponential function such that if you have log base b of x equals y, b has to be greater than 0, b cannot equal the number 1, and x has to be greater than 0. The x is called the input or the argument. The b is the base, and y is the output or the power. And the way you read as log base b of x is y. Now this is the rule, because we're going to learn how to switch it from logarithmic form to exponential form. So here's the logarithmic form. It's going to be log base b of x equals y. And this can be written as exponential form. Now, the way to write it as an exponential form, since this is your base, that's going to continue to be your base. Your base is going to be b. You're going to raise it to the y power, and it's going to equal what the input is. So it's going to be b raised to the y power equals x. Now, common log is always going to be base 10. So if they don't have a base there, it's going to be an automatic 10. You just don't see it. And the way that you write it is you just write log of x. So you notice how there's no number right here at the bottom? The base is assumed to be 10. Now, this is going to be a natural log. Now, that base is going to be the letter E. Now, E is on the calculator, and it happens to be where the ln key is at, where the natural log key. So that's a base E, and we write it as a natural log of x. That's ln of x. So like on my calculator, here's the ln key. Right there's the ln key, and then there's E. Now, even on a scientific calculator, it's going to be like that. Now, in order for me to access the E, I would have to hit shift and then E, or second and then E. Now, E actually has a value. It's not a variable. It actually has a value. I'm going to start off with an example. I want to write in logarithmic form. So I want to write it in this form. I'm going to give you exponential form. Now, so this is exponential form. Now the base is 6, so the 6 is going to go right here. So this is going to be a log base 6. Now the y value is on the other side of the equal sign. So, and then the variable, that's the variable, and the x was on the other side of the equal sign. So equals, or actually, sorry, 216 equals 3. Now look, 6 raised to the third power equals 216. So right here, the b is the 6, the y is the 3, the x is the 216. So log the b, the x, and the y. Right here, we have the b is going to be the 5, the y is going to be the x, and the x is going to be the y. So this is going to be a log base 5 of y equals x. Now these ones are going to be a little bit different. Now the way I always remember it is ln and e are inverses of each other. So if I take the ln of the left side and the ln of the right side. So if I take the ln of this side, the ln and the e cancel each other out, and I'm just left with a -2. If I take the ln of this side, I need to take the ln of this side, which is just going to be natural log of 0.1353. Right here, I'm giving you, once again, in the exponential form. So the b is the number 2, the y is the -3, the x is a 0.125. So to write in logarithmic form, log, the base is going to be the 2, the x is going to be the 0.125, equals the y is the -3. Now let's go from logarithmic form to exponential. These ones are easier because I'm going to do the scoop. So I'm going to start off with 4. So it's going to be 4 exponent square equals 16. Or if you want to use the formula, the b is going to be the number 4. So where b is at, put the 4 there. The x is going to be the 16, which goes on the other side of the equal sign. And then the y is going to be the number 2, which goes as the exponent. On this one, if you notice, there is no base. But remember, common log is if there's no number there, we're going to assume it's going to be a 10. So right here, we're going to assume there's a 10. So that's going to be 10 to the -3rd power equals 1 over 1,000. And remember, the definition of a negative exponent means it's going to be a denominator. You have a cube on a 10, so that's 3 zeros. On this one, ln, the opposite of ln is going to be e. So and e is going to be a base. So it's going to be e raised to that power, which is the ln. So those cancel out, and I'm left with a 12.1825. If I take e of the left side, I need to take e on the right side. Now, e is a base, 2.5 is an exponent, so that's going to be e to the 2.5 power. Let's go on to example 3. Now to solve this, I'm going to go ahead and I'm going to write that as an equation. So I'm going to say the log of 381, I'm going to set that equal to x. I'm going to change that to exponential. So that's going to be 3 raised to the x power equals 81. Well, if I go by my exponents, let's see here. Let's go by my exponents. If I have a 3 squared, that equals 9. If I do a 3 to the third power, that equals 27. 3 to the fourth power, that's 27 times 3, which is going to be an 81. So right here, that means that the x has to equal the number 4. So my answer here is going to be the number 4. 3 to the fourth power equals 81. So if you have log 381, that's going to equal 4. I'm going to set that equal to x. That's going to be 2 to the x power equals 1 over 16. Now, in order for it to be a denominator, you have to have a negative exponent. So I know that's going to be a negative exponent because it's going to throw it on the bottom. Now, I'm going to do powers of 2 and see which one gives me a 16. 2 squared equals 4. 2 to the third power equals 8. Well, 2 to the fourth power equals 16. So right here, the x, if I make that a 4, I'll get the 16, but I want it to be a denominator, so it has to be a negative 4. 2 to the negative 4 power equals 1 over 16. Therefore, x must equal negative 4. So your final answer here is a negative 4. Right here, we have log of 0. Now, I'm going to go ahead and I'm going to write log of 0. I'm going to make that equal x. There's an automatic base 10. You just don't see it. So that's going to be 10 to the x power equals 0. Well, let's see here. If I have 10 to the 0 power, that equals 1. 10 to the 1 equals 10. 10 squared equals 100. Okay, so obviously it's not going to be a positive exponent. Let's try a negative exponent. 10 to the negative 1 is a 1 over 10. 10 to the negative 2 is going to be 1 over 100. I'm never going to get a 0. So this one does not exist. Does not exist. You cannot take the logarithm of 0. You can never take the logarithm of 0. On this one right here, I'm going to set log 4 of 4n equal to x. If I do my scoop here, it's a base of 4 raised to the x power, and that's going to equal 4 to the n. So in this case, since your bases are the same, the exponents are going to be the same. So here, x is equal to n. So what I was looking for x at the beginning, it's just going to be an n. One thing about these are actual patterns. If you have a log base, if these two are the same number, they're going to actually cancel out and you'll just get whatever the exponent is. For example, if you had like log 7 of 3, the log 7 cancels and the final answer is just going to be 3. So just keep that in mind. Calculator time. We're going to use a calculator to evaluate each expression. And I want you to round to the nearest 10,000th. Now, 10,000th, that is actually 4 decimal places. Make sure you're getting these values on your calculator, because if you're not, I need to figure out what you're plugging in. So you'll have to show me so that I can correct you, because I don't want you to get it wrong on the test or the quiz or on the homework. So go ahead and try these first on your calculator. I'm going to go ahead and plug these in now. So logarithm of 13. So I have a log of 13. Now I'm going to go to 4 decimal places. So 1, 2, 3, 4. The 4 does not make that round up. So the answer is going to be 1.1139. The logarithm of 800. So I'm going to hit log of 800. Now the calculator is automatically going to put it in base 10. So 4 decimal places ends right there at 30. However, that 8 makes that 0 round up to a 1. So the answer is 2.9031. Natural logarithm. Natural logarithm is the one with the ln, and it always is attached with the e. So I'm going to ln of 1.05. So 4 decimal places ends right there at the 8, and the 0 does not make that 8 round up. Oh, actually, it's 1.05. Sorry. Natural log of 1.05, not 0.2. So there's 4 decimal places. But remember that 9 makes that 7 round up. So it's going to be 0.48. And it's not going to be a 7. It's going to be an 8. And then the last one, I have a natural log, parenthesis. Now I'm going to type in a -4. Don't hit subtract 4 because negative and subtraction are 2 different keys. I want a -4. Uh-oh. It's not coming out. It's an error. So I cannot take the natural log of a negative number. So this one, since it says error, I'm going to put undefined. And that concludes our notes.